going to skip. All right. For pre-AP people that are watching this video, I'll come back at the end and record that problem. So that'll be at the end of the notes. All right, but we're going to keep going. Thorough. All right. So now we're going to multiply two rational functions together. So we're just multiplying our numerators together and our denominators. But let's go ahead and factor it. Which one of these is going to be complicated to factor? Left, this one with a 2? All right, so let's do that off to the side first. All right, so what do we need? A times C, which is 2 times 3, which is 6, and factors of that add to get 7. So what? 6 and 1. Woo, y'all are good. All right, where do I put those? Okay, so 2x squared plus 6x plus 1x, and then plus 3. Our caboose comes down. Put our dotted line in there. Now what?
2x.
Comes out of the front?
Yep.
Okay, so what does that leave us with?
X plus 3.
Very good. All right, what comes out of the back? Just a 1. So we still have x plus 3. Did our parentheses end up being the same?
Yep.
Yes, so we're on a good roll. So what are our two factors? 2x plus 1. Very good. All right. So now we can go back and work on everything else. So we have x plus 3, 2x plus 1, and that one's over x minus 4, times, how can we factor this one? We need 4 and negative 4, because I have to multiply to get negative 16 and to get 0. So we get x plus 4 and x minus 4. And then now let's factor the last denominator. Adds to get, or multiplies to get 15, adds to get 8. 5 and 3. Now it's time to cancel. What all cancels? X minus 4 and x plus 3. So you don't have to like FOIL it all out. It's okay to leave it like this, as long as everything's canceled. All right, what else do we still have to do? Yeah, the restrictions, the points of discontinuity. So what do we set equal to 0?
X plus 5, x plus 3.
Yeah, so let's just set each factor of the denominator. So x plus 5, x plus 3, what else? X minus 4. Sorry, that got real messy. All right, so x equals what for all those?
Negative 5.
Uh-huh.
Negative 3.
Uh-huh.
Positive 4.
Very good. So just write those down. X cannot be negative 5, negative 3, and 4. All right, next example is dividing. So we're dividing fractions. So if I say, if we have A over B divided by C over B, what would we do? Do y'all remember how to divide fractions?
You turn around to C and B and then you multiply.
Yes, we have to mess with this C and B. We need to turn the division into multiplication. So A over B times the reciprocal, b over c. So you just flip the second fraction and it becomes multiplication. All right, so that's what we're going to do. Let me, oops, it's not going to let me erase it. What the heck? I'm having trouble. Okay. All right, so we're going to have x minus 4 over 3x plus 2 times x minus 2. And then we multiply by the reciprocal. So we're going to switch. So x minus 2 is on top with 7y minus 5. And 5 times x minus 4 is on bottom. All right, what can we cancel? X minus 2 and x minus 4. So we get 7y minus 5 over 5 times 3x plus 2. And you can leave it like that. Now, the restrictions become a little more intense when we divide like this because we have to use all denominators. So that means the ones we started with and the ones we ended with. So for our points of discontinuity, we're going to set, we need to use both of these. These started out as denominators, and these ended up as denominators. So we have to use all of those. So 3x plus 2 equal to 0, x minus 2 equal to 0, x minus 2 again, so I'm not going to write it twice. 7y minus 5 equals 0, 5 equals 0, well that's just not true. Okay, and x minus 4 equal to 0. So we're going to end up with 4 different values here. Does that make sense? You have to use anything that was ever a denominator. So we changed the way it looked, so we had to use what the denominator was before we changed it and what after we changed it. All right. So here, let's subtract 2 to the other side. And then we'll divide by 3. So x equals negative 2 over 3. The next one, we'll just add 2 to the other side, so x equals 2. The next one is y, so we add 5. 7y equals 5. Divide by 7. Y equals 5 over 7. And then the last one, x equals 4. So now let's just list those out with our answer. So what can x not be?
4, 2, negative 2/3, and 5/7.
4, 2, and negative 2 over 3. But the 5 over 7th, that's y. So y can't be 5 over 7. Okay. When it says state the restrictions on the variables, it means any variable. So you got to do x and y. Or any other letters that they give you. You know, it's algebra. We got letters and numbers together. It's the best, right?
Yep.
Right. Okay, so you have 18 homework problems. So kind of 6 of each type that we did. All right, for this example 2, it says one factor in designing a structure is the need to maximize the volume, so the space for working for a given surface area, the material needed. So we want to maximize our space for the materials we have. To do this, we're going to compare the ratio of volume to surface of a cylinder with radius r and height r to a cylinder with radius r and height 2r. So basically, we're trying to figure out, is it better for our height to be bigger or not? So our first radius, so cylinder 1 has a radius r and height r. The second one is radius r and height 2r. So we're going to plug these into a ratio using these formulas. So basically we have this over this. So let's plug them in. So we have pi, r is r, h is r, over 2 pi r is r, h is r, plus 2 pi r is r squared. Alright, so let's simplify that. So pi r cubed over 2 pi r squared plus 2 pi r squared. Well, that is pi r cubed over 4 pi r squared. Now we just need to cancel. The pi's cancel, all the r's but 1 on top cancel. So we end up with r over 4. All right, let's do the other one. So we plug into the formula. So pi r is r squared, and then we plug in 2r for h over 2 pi r, and then 2r for h, plus 2 pi r is r squared. So let's see, we get 2 pi r cubed over 4 pi r squared plus 2 pi r squared, which is 2 pi r cubed over 6 pi r squared. So let's cancel. So we're left with 3 on the bottom now. Pi's cancel and all but 1 r. So then we get r over 3. So which has the best ratio, the biggest ratio? The one with the 3, the third. So ratio is greater for height 2r. So that's the one we want to use. There we go.